Welcome back to our grade 10 maths lessons. I'm Miss Aminup, your maths teacher. In our last lesson, we looked at the last topic on polynomials and how to solve polynomials using factorization. In today's lesson, we're moving on into a new topic, which is on inequalities. All right, inequalities. Right. Okay, inequalities are mathematical statements that give the solution to x. Okay, now we've learned about equations, and equations that come in this form y equal to mx plus c, we know are linear equations. Okay, so any equation that comes in this form is linear, and for inequalities, we use the equations here, but in place of our equal sign, we use the inequality symbols. Okay, now what are those symbols? We will go through them. Okay, we have, let me see, the first one is this symbol. All right, then we have this one. Okay, the arrowhead that points to the left is your less than symbol. All right, and the arrowhead pointing toward this direction is your greater than symbol. All right, now how do we remember this? I've always told my students, place your hands on your hips like this and you will see the inequality signs. Your left hand is your less than symbol and your right hand here is your greater than symbol. Okay, now where you see a stroke just under the less than symbol, this means less than or equal to. Okay, and the greater than symbol with a stroke just below here would be greater than or equal to. All right, now how do our inequality statements look? Just like an equation, but without your equal sign. So for example, let's have a couple of inequality statements. We can have x greater than 4 or x less than -3. We can have combined inequality statements where we have two of these put together. Okay, so we can have inequality statements that look like this: -2 less than x and less than 8. Now remember, we use inequality statements to help us find the range of values that give us a solution of x. Okay, so we are going to do that. We can find the solutions using a number line. Okay, a number line. So let's have a look at a few of these equations, inequalities rather. All right, now example number 1. Let's have a look at x greater than or equal to 3. Okay, so we are going to find a range of x values that satisfy this inequality statement. Okay, now before we get to that, we use what we call closed circles and open circles. Okay, now where you see a shaded circle, this is a closed circle, and a circle that is not shaded is an open circle. These are used to describe this statement on a number line. Okay, so we're going to use them to show how they are used. Okay, so on a number line, we have x greater than or equal to 3. So let's have a range of values here. -1, let's go as far as -2, 1, 2, 3, and 4. So it says x is greater than or equal to 3. That means any value that is greater than +3. So we're going to put a circle here. And because it says equal to 3, we have to shade in that circle because 3 is included in the solution. So any value greater than positive 3 is a solution for x. Okay, now let's try another one, this time using a negative number. Okay, x is less than negative 2. Okay, again, all values of x which are less than negative 2. So let's put this on a number line, and we see the range of solutions that are equal to x. Okay, we have negative 1, negative 2, negative 3. All right. Let's see. So all values of x less than negative 2. Now remember, there is no stroke here under the less than sign, which means that negative 2 is not part of the solution. Okay, so we use an open circle to describe that. Okay, so x is less than negative 2. That means our arrow is going in this direction. All values to the left of negative 2 are less than x. Okay, now sometimes an inequality statement can be combined, meaning this and this can be put together and they form a longer statement. Okay, we'll have a look at an example of such. Let's see. The statement 4 is less than x, which is less than 7. Now this is a combined inequality statement. So in order to put this on a number line, we have to break this down into 2 separate inequality statements, and that makes it easier for us to put this on a number line. Okay, so look at the first value here. If 4 is less than x, that means that x is greater than 4. So you rewrite that part of the statement as x greater than 4. All right? X greater than 4. The other half of the statement has x less than 7. Now, if you are to break up the statement here, remember x comes before the number, and that's why this sign here is reversed. Okay? So if I put this on one number line, let's have a look at our number line. Done our values very quickly. All right. So our first inequality says x is greater than 4. That means we are using an open circle, all values greater than 4. Then we have x less than 7. So we have another open circle here, and that includes all values less than 7. Okay, now looking at the way the arrows are sitting, that means that our solution will lie between 4 and 7. Okay, so the solution of x, or the value of x, will lie between 4 and 7, but will not include the two numbers 4 and 7. Okay, so that means the solution will be from 4.1 up to 6.999. Okay, any number but not including those whole numbers there. Now let's look at another example of this. This time we will look at negative 3 less than or equal to x, which is less than or equal to 2. Okay, so we quickly draw up our number line. We have, okay, okay, there's our number line. Now we have to break this inequality up into 2 separate statements. Okay, so if negative 3 is less than or equal to x, That means x is greater than or equal to -3. So let's rewrite that. X greater than or equal to -3 and x less than or equal to +2. Okay? So x greater than or equal to -3, because it is that equal to, we have to shade in our circle. So all values greater than or equal to -3 and x less than or equal to +2. So values less than or equal to are going in this direction. Okay, so where do the solutions for x lie? The range of solutions will be from -3 up to +2. So here is where the solution for x will be. Okay, I hope you've learned something interesting. We are going to look at calculations this time to solve for the value of x in our next lesson. I hope you can join me then. See you.